Hello and welcome to another free code session. My name is Jason Bach. I'm going to do another episode today, and I just tweeted out my shirt with my Rush shirt on and Happy Birthday Neil on it and all that stuff, and I think I've gotten over 100 likes on it, which, you know, for whatever, I didn't do it for that. I did find it interesting that the actual Rush account retweeted it, which was a nice little touch, so thank you. But I've been doing some more work this afternoon. It's like I'm reading this book called Wonder of Numbers, and it's all in the history of mathematics. It's it's not a deep technical book, more just going through the history of who came up with what, when, and how. And they talked about Zeno's paradox. You know, if you're running faster than the hare, but you both get to the same point, because you're doing it the infinitesimals and smaller and all that other stuff. I feel like I'm getting closer and closer to actually starting to generate code, but I'm never quite getting there. One thing I decided right now is to, change this up so that I actually see the internals here. So I actually put an internal visible attribute onto this. And what I want to do, I debated this back and forth in my head, but the reason why I've changed this is to go kind of back to what I usually do, which is have the test assembly, see the internals, and then keep those internal. Yes, somebody can get around that by calling their assembly rocks.tests, but why would you want to do that? That seems pretty, kind of a pain in the butt if you'd really want to go that route and do that. So I'm okay with it. I'm fine with it. And I know you can actually, I think, put in the full name of the assembly if you sign it and everything else. But nah, I don't want to do that. I think keeping them internal, and if somebody really wants to see the internals that way, hell, they could use reflection. I mean, it's an indicator to say, I should be able to test this, but you really shouldn't have to be able to use this. So to that point, a lot of what I realize what I'm doing in here really shouldn't be done with the mock information class. That's only to gather stuff and then tell me. How it gathered it, to me, is not really as important here. What is important is when I say, hey, get me all the constructors off of this type, give me all the methods off this type. That's where I should be doing this test and focusing it there. And there's going to be a tricky test that I just came up with because I did add something to say, can this be seen if you're in this assembly? So what I'm going to have to do is actually generate an assembly and then reference that from the second assembly, and then come up with the cases of could I actually see that or not. So this is going to be a lot of just moving around. But again, I think that there's still enough foundation I need to build before I continue on and actually say, okay, I'm confident that I can move and actually generate the code. Because quite honestly, there's a part of me that goes, I think that's actually going to be somewhat of an easier part. I could be wrong, but I feel like this is important to get right, or at least close to as right as I think it should be. Okay, so let's start moving tests around and putting them in the right spots. I don't want to deal with the iAssembly test just yet. That has to do with checking if if the one assembly can see another. And I'm not really, I don't know. I just, I don't want to deal with that one just yet. So method symbol. We can see match. Why do I have, oh, yeah, I don't need to test an enumeration. What I do need to do is test this and say, do we have matches? Okay. So let's actually come into here because I feel like I'm going to be pulling a lot of this code generation stuff together. So method symbol. So the first thing we want to test is matches. So we'll say test public static void match when methods are exact. My stomach is like growling right now. It's quite funny. Yeah, we want to do it no parameters. And then we want to say test public static void match when methods are exact with parameters. My God, if you can hear that, it's just, I hate to bring that up, but I don't know if I said this before in previous episodes. Can't remember, but I think I talked about that I've been trying different salsas, and the salsa that I'm on is a hotter one for me at least, and it uses habanero peppers. And I'm kind of wondering if that's irritating my stomach a little bit, because when I've tried it when I've had it the past couple of days, it seems like I just get this where my stomach is constantly like howling afterwards. I don't feel sick. I don't feel like cramps or anything like that, but it definitely is not shutting up right now, and it's kind of annoying. But like, you really cared to know about that. Okay. With parameters, I guess, well, yeah, because I can come back here and copy that anytime. Parameter, params parameter with ref parameter, and it really doesn't matter. I mean, that doesn't matter. Methods match when methods differ by return type. Match when methods do not match by name, or they don't match by parameter count. Okay, match when methods do not match by parameter type. I can't type, and then by parameter modifier. Okay, and then we'll come here and we'll grab this and we'll say, now what do I want to do here? I'm going to do that. I'm going to basically have, I'm basically going to have, I don't know if I need to, oh, fine, whatever. I don't think I need to concat that though. I don't think, because that has nothing to do with, these tests don't have anything to do with rocks. So what I want to do is get the two methods, do a comparison on them, and then get the method match. Okay, so we're going to say match methods. Yep. And then we're going to say that's the source. Then we're going to say string method 1 name and string method 2 name. So we're going to look through the tree and just say, hey, find me one, find me the other, and then compare the two, because I think that's what this is, just by method symbol. Yeah, so it doesn't matter. Okay, so we're going to say syntax tree give root descendants of type method declaration. Method declaration syntax, where the method 1 syntax is going to be where matches method 1 name, and then this one is going to be method 2 syntax, where we're going to be getting a method 2 name, and then we're going to say method 1 symbol, which is going to be method 1 syntax, method 2 symbol, it's going to be this method 2 syntax, and then we're going to return method 1 symbol match method 2 symbol. Okay, so now let's do this in a test. So we're going to have here, we're going to say var code is equal to, and then we're going to have that, say public, and we want to have, yeah, let's do that. Private const string method 1 name is equal to method. It doesn't. Yeah, we're going to do that trick. Name of method symbol extension test method 1. And then we're going to have method 2. What? Okay, now so we're going to say here that we're going to do that. We're going to have public class 1. It doesn't matter what it's called. And we're going to have exact. So we're going to say public void method symbol extension tests method 1. Did it? Okay. Actually, I can't forget that. That screwed me up on a test I was working on today. I forgot that I was doing a constructor and I needed the parentheses, not the braces. Okay, so we're going to have class 1. Now we need to have class 2 because we need to have the exact same method except in a different class. And by the way I did the search, that will be fine. So we'll say public void method 2, and then we'll say assert multiple. Yes, I'm following that even if I'm only going to have one. I'm going to say assert that method symbol extension test match methods, or this is the code. And we don't need to pass in, if we're going to use those all the time, we don't need to pass in the method. We're just going to use those all the time. So we do that. We say identifier text is equal to method symbol extension tests method 1 and method 2. Yay, we come back up here. We match the methods is equal to, and we should say method match exact. Okay. Run this. One failed, but was none. Really? Well, why is that? How dare you? How dare you say that my code is wrong? Because it probably is. Actually, those two could be in the same class. It doesn't matter because they have different names. Oh, hi, yes, they have to have the same name. Duh, I'm a moron. Method name. So this also has to be name. Of course, this leads to a conundrum now. So now I need to say, what classes are they in? So I could just have two classes that I always use, and I just put them in different classes. So we'll say private const string class 1 is equal to the name of class 1. And we'll have class 2. And we'll do that. And then we'll say here class 1, because that works. And then we'll say down here class 2. Okay. And then we'll say this is actually just going to be method. It really doesn't matter. Public void method. At least it shouldn't. Okay, so now we say single is equal to, the identifier text is that, and, okay, we're going to have to be a little bit, we're going to have to say of type declaration syntax, single, where the identifier name text, whatever, is equal to I'm method symbol extension class 1. So we get that. And then we say descendant nodes and tokens on that one. And then we get the method declaration syntax where we get that one. Okay. So now we need to do the same thing for method 2. We can do that by just copying this and doing that. Two, and that should work. Okay, now if we do this, yes. Okay, we do have a, well, shoot. There's going to be a test down below that's going, we need it to not match because the method names are different. Or no, I'm sorry. Yeah, the method names are different. So to that point, we're going to say because we want to say which method are you comparing. And we're going to assume the first one's in the first type and the second one's in the second type. Okay. And it's okay in this case to say method 1 name string method 2 name. The 1 name method 2 name. Okay. So now this should be okay because we're using the same method for both of these, and we know that they match exactly. We can anticipate we're going to need a 1 and we're going to need a 2 at some point. Okay, but that's okay. All right, match when methods are exact with parameters. Okay, so now we need to have int A, and these should be okay because they're going to, yep. With params parameters, whoops, no, not that. So we're going to take this and we're going to say params object B, and that should be okay. And that passes, yay. With ref parameter, okay, so now we can say ref int A. Well, we can say here with what do they call the same modifiers. Okay. And that should be okay. And it is. While we're here, we're going to say out int A. And in this case, we have to be a little careful because we need to say like A is equal to 3 because we have to, it's an out and we have to initialize it out just to be correct. This should be none, and it failed. Why did it fail? It was exact. Well, okay, good, because that was something I assumed, and apparently that's not correct. Different by return type only. Okay, so we'll take this, and we'll say this is int, and this is string. In this case, we will not have any parameters because we don't care. And so we're going to say differ by return type. And in this case, it should work. Yes, it does. When do not match by name. Okay, so now I have to change it up a little bit. This one, we're going to have method 1. This one, we're going to say, again, void. It doesn't matter because it's never, we know based on how the code works that we'll never get to, so we're going to say match 1 2, and this should be none. So we should not have a match here, and we don't. Okay. By parameter count, we can go back to having 1 here because, again, same method name. So we'll do 1, and then we're going to have just an int a on there, and this should also be a none. Okay, and that's true. And by parameter type, this one will have a string of a, and those should not match either. What did I screw up? Yeah, I think I missed a semicolon. Yes, I did. Okay, that's fine. And that's good. Now we know this one's not right. So this is good. I'm actually pretty happy with this because we're obviously not doing it right here. So why is this? Method 1, class 2. Okay, that's right. Okay, so we can do that and do that. Okay, so the cell parameter types, the other parameter type is not helpful. That ain't helpful at all. They're the right types, right? They're the same types. They're both ints, yeah, okay. They are not params. Okay. So this is where my compact coding style gets a little problematic. Let's take this. So they do equal. Okay. And now we need to say our custom modifier is equal. They do equal. They equal as well. And I know that this params is true or false. I'm sorry, false. So something in here, they don't have custom modifiers here, and they don't have ref custom modifiers, even though we did say they're ref and out. So that's a problem on my part. Is I did. Oh, so they're a ref kind, but then how do you know if it's an out? The discard is optional as params is this. No lambda or no. Ref custom on or ref kind type. Kind, it's a parameter. It's a metadata name, original definition. Well, how would you know it's an out and not self parameter ref? Whether it's passed by value or by reference equals other parameter ref kind. Yeah, we need to find. So I get this, and now this should pass, I believe. It means I can get rid of that custom modifier lookup thing. Right, because they are different. But what happens if we said here out and out? Clearly they're going to probably equal, but what I really need to say is, does an out and a not out, does that matter? For example, could you have public class A void foo? Yeah, because would they be on the same type? Foo int a. And then could you have a void foo out int a, where you do that, and then you say a is equal to 3. And what's the problem? Private member a. Well, it doesn't say anything. Like if I made this private, okay. Fine, we can make it static too. That doesn't really matter. Fine. Jesus. And now it's just saying this is unused. So actually that's okay. Okay, but if I said ref here, is that okay? Can I do that? That's apparently fine. So it's fine, but they're not exact, correct? And the reason why I'm doing this is because I need to figure out, if I have interfaces, how do I implement them? Like, for example, let's say I have public interface IA, which has void foo, which takes an int of a, okay, and now I have public interface IB, which has a ref into that. Now I say public class AB, which implements IA and IB. Okay, so now how do I do that? I say implement interface, and that's okay. So they don't match, which is fine. But now if I change this, so it knows I don't implement it. Right. So it knows, okay, so now if I made this obviously an out, that would be problematic, because if I made this an out, well, now I've got two methods with the exact same signature. And if I do this and I do that, then it's basically saying, well, this implements both of these. You're satisfying the contract. I can explicitly implement these two interfaces, and that's fine. But I do want to know that, like, these are exact. That isn't. And so it should bark and say, yeah, you didn't implement IA. So now I should be able to, and so those are two completely different methods. So the point of what I'm saying is those should not match. Okay. And so if I come back down here, and what I'm trying not to get a match here is I want to say that should be none. But what's coming out is that these are, well, fine. Go away. Go away. Okay. These should be none. And I think what's coming back is saying it's, oh, that's interesting. Well, technically it's by ref. Sorry, I got to do this one more. I may have already done it and I didn't realize it. IA, which is equal to void foo ref int a, and I say public interface IB void foo out int a, and now I have public class AB, which is IA and IB, and I say implement this, and I implement this. But now, yeah, so that little refactoring thing says, fine, I'm going to implement it. But then you look at the actual definition of the class, and these have to be different. Okay. So what you could do to get around this is determine that these are actually matched and say IA dot that, and then say here void IB dot that. And then you're good. And that satisfies implementing those interfaces. So in that case, those should be exact. So if I have the same modifiers, what should happen is when I say with ref and out modifiers, because I want these to come out as being exact. And if they're not, then we have a problem. We have to somehow figure out how do we, yeah, and it's a problem. It's going to say they're none. Because one is saying it's a ref and one is saying it isn't. So somehow, let's see if we can quickly figure out when I run this, because I'm actually past 30. Well, close to it because I had to edit some stuff out. But if I come through this, there's got to be a way to say on self parameter, that's going to say its ref kind is ref. The other kind is going to say its ref kind is out. Okay, so let's stop here. Get this out of the way. Let's just say, what are the ref kinds? There's none in out ref read only. Okay. So we want to say they either equal or one is a ref and one is an out, and or vice versa. Or self parameter is equal to ref kind ref and other parameter ref kind is equal to ref kind dot out, or we want to do this in parentheses, or the other way around. Ref out. And then we say the rest. There. Okay. So we're going to say if the type's equal, you're good. Okay. But we're trying to find the opposite. We're trying to find immediately the case where they don't. So if they don't equal, you stop. Or if the ref kinds don't equal. So if they do equal, you're good. Or one's a ref and one's an out, and one's an out and one's a ref. And then we don't need to do this because this is completely worthless. And so I think I can take out this one because nobody's using it. Okay. All right. So let's come back up here and let's see. Do we now pass all these? And we do. Let's come to this, go to tests, and we shall say shift F10, test, run all of them. Did we break anything? And we didn't. Okay, so I'm going to commit this. But so now I got to do the rest of these and break them all out. So I think I'll do that off camera. But I was trying to illustrate the point of this is what should actually this is what I should actually be testing for each of these individual methods. When I get back to the mock information one, all I care about is, do you have a path that says, yes, I had at least one? That's all I care about. When I give it a class, do I get all the methods I expect out of it? That should be in a method symbol extension test. That should not be here. And in fact, these should be method symbol method match extensions, method match tests. So because if I look at method symbol extensions, there's the match one. Oh, you go away. Okay. And that's it. So that's fine. I thought there were more here. But like with type symbol here, there's get mockable constructors, that's going to have so many different cases that I'm going to be pulling out from that. And so in this case, it's okay. I think when you have extension methods, probably what you want to do is have a test class per method that you have in the extensions. So to follow that, I'm going to have a method symbol extensions match test. Yes. So these are doing all the matches. And then if I added another method to method symbol extensions, I would add another test class to test those and keep them separate. Whatever works. So that is what I'm going to do for right now. I'm going to probably do some stuff off camera. We'll do off camera, getting more tests around everything and getting it to the point that I think once I get these tests in place, then I'll be comfortable enough to say, okay, let's now actually start diving into generating the rocks code so we can finally see, am I actually going to be able to mock using generators? That's going to be the big one. So thank you all for watching, and leave comments and questions below. See you in the next episode.